Hello students, in today's video we are going to see deeply how the entropy is related with the reversible process and irreversible process. In the last lecture we have drawn a diagram which was cyclic and reversible process. Let's say it goes like this from this point to this point, which is path R1. Here it was initial point A and final point B, and it was a cyclic process, and that's why we come by the another path, let's say R2, to complete the cycle. In that case we studied that the heat is coming in from the path R1 and it is going out from the path R2. Now consider the system and surrounding. What will happen to the change in entropy for surrounding? So before going to see the entropy, we will see what is the change in heat for the system and for the surrounding. So the change in entropy for the system in R1 process, that is first process, is equal to plus dq upon t, because you can see here that the heat is absorbed, and for the surrounding ds will be minus dq upon t. So the total change in entropy of the universe is 0. Now similarly for the next cycle for R2, ds for system at R2, this will be equal to, now in this case the heat is rejecting out, let's say it is exactly equal to the previous case, and again for the ds for the surrounding it will be dq upon t. Now if we add all these terms we will get 0. So this suggests us that in a reversible and cyclic process the total change, net change in the entropy is 0. So for reversible process only the change in entropy is equal to 0, because you can see here the path is retraced and the s is become the same as the initial path. So in this case the initial and final states are same in TS diagram. Remember we are drawing this TS diagram, and that's why the initial and final entropy is same, and therefore the change in entropy is 0 in this case. Remember this is reversible and cyclic process. Now we will see if the process is not reversible, because see all the natural processes are irreversible, they are not reversible, and therefore we need to study how the entropy is changing if the process is irreversible. So we know the definition of ds, that is equal to integration of dq by t from initial to final position. Now let's say this is SF, that is final entropy minus initial entropy, which is this integration from I to f dq upon t. Now we know what is dq. We can write dq in terms of cp dt. So this is nothing but cp. I am taking this outside of the integration, assuming that it is constant dt upon t. Now we can integrate this and we get cp ln tf upon ti, final temperature divided by initial temperature. So this is positive quantity, this is greater than 0, because cp is always positive and log of any function is always positive, and therefore sf minus si is always a positive quantity. So sf minus si is always positive, or we can say sf is always greater than si. So what does this tell us? This is initial entropy and this is final entropy. So for any irreversible process the initial entropy of the system is less and it gradually increases to become maximum, and that's why we have also seen the principle in some earlier videos, earlier lectures, that entropy of the system always increases, and that's why we also call that the entropy of the system or entropy of the universe tends to maximum. So this is the basic principle of the increase in entropy. Here we have assumed that the process is taking place at constant pressure, because we have seen we have used a CPDT. Suppose the process is not at constant pressure, but in general or for isothermal process we can say, so we know dq is equal to pdv. Now using gas law we can have p is equal to nRT upon v. So if we put this here and rearranging, we can take t to this side because we want dq by t. So we will get dq upon t is equal to nr dv upon v. And now again this is ds. So integrating on both sides we get delta s is equal to, this is integrating, is equal to nr ln of v final upon v initial. Again you can see here n is positive constant because it is number of moles, it cannot be negative. R, it is gas constant, we know the value, that is also constant. And here is again the log function, so it is also positive. So in any way, in any process you can go, because this is more general way. We have seen in this case this is work done, so du is equal to 0, so that is isothermal process. But still you get the positive quantity which is SF minus SI, because this is total change in the entropy during the process. So you can see this is also positive quantity. So I just showed you two different processes. First one was isobaric and second one was isothermal. But in any case you will find out that the entropy change is equal to positive quantity. So we can write SF is always greater than SI or delta S, which is the entropy of total system, that is total change in entropy during this process, during the process is always positive. And this says that the entropy of the universe tends to maximum. So in this case universe means we are including system as well as the surrounding. So there is net change in entropy during the irreversible process. So any natural process tends to increase the entropy.